So each of these rows corresponds to the same person. So this 65.5 goes with the 63. This 67.75 goes with the 66. Do you guys see that? This is called paired data. So we've got paired data. Each row corresponds to the same observational unit. And you want to be careful with paired data that you never want to reorder the data unless you reorder it together, because we always want the 61.75 here to be matched with the 62.5. We always want that person to be matched with themselves. So be careful when ordering paired data. That's something you really want to be sure that you order the two columns together. Okay. But what I'm going to do is make a scatter plot. So where do you think I'm going to go in StatCrunch? Where am I going to go to make a scatter plot? Anybody? Scatter plot's a graph, isn't it? So where am I going to go?
To graph.
To graph. Makes sense. So graph, and then down here we've got scatter plot. And I'm going to have my X variable. I'm actually going to have my X variable be the arm span. And from the arm span, I'm going to try to predict the height. So the X variable is going to be what we call the independent variable. So let me write here that X variable is what we call the independent variable. Independent variable. And then the Y is what we call the predicted. Sometimes you might hear that called the response variable. Dependent or predicted variable. Okay. And then I'm just going to, again, just leave it at that. I've just got my X and my Y. I'm just going to push compute and be ready to go from there, because less is more when you're first working with StatCrunch. Later on, we can do some things, but we're just going to move these. So the X is the independent variable. And so the arm span is going to be my independent. So when you look at this data right now, what are you noticing about either shape, trend, or strength? What do you guys notice? Actually, in the chat, in a private chat to me, go ahead and type in what you think the trend is. Is it positive or negative? I got it. I got it, Bishop. Good. Good, Kim. Good, Lizeth. Good, Benny. Cool. So most of you are writing again that it's positive. That's very good. That's exactly what we want. And what that means is we see a positive trend. And that's telling us as arm span increases, what happens? The height, and again, tends to increase. And I'm going to put that phrase on average. Doesn't always happen. Some people had something a little different happen, but the height tends to increase on average. What shape do you guys think this looks like? And you have two choices. Do you guys think it's linear or not linear? Type it in the chat if you want. I've got one person saying linear, one person saying non-linear, another person saying linear. Good. and this is what's hard for you guys because you're used to linear being perfect. Lizeth wrote, it is somewhat linear, but it is kind of scattered. And that's absolutely right. I would definitely say this is a linear shape. We do have some scattered stuff going on, like here, it feels like it really breaks the mold. Oh, did that too. It kind of breaks that pattern. But overall, if I were to look at overall how it's generally tending, it looks like we've got a linear shape going on. So I would say this is linear. And it was nice the way Lizette said, with a little bit of scatter going on. Okay. So because of the scatter, I would say this is a moderately strong linear shape. Personally, I know how this data works. This is actually I would guess an extremely strong linear shape. But you guys, I know being new to this, you might not see that just because you're not used to seeing lines with scatter. So here's something that it mentions in the textbook about the line y equals x. So this line y equals x, do you guys remember the equation of a line? Do you guys remember slope and y-intercept of the line y equals x?
Not like y something equals mx plus b.
Good. Y equals mx plus b. So the m, the coefficient in front of that x is actually the number 1. So remember y equals mx plus b. I'm going to change this too. This is our general equation of a line. So when we compare this, notice in the line y equals x, we've got the slope, which is our m, is the coefficient of the x terms. That's just going to be 1. And then what's the b in that equation? In the equation y equals x, do you see a plus anything going on? Do you guys see a plus anything going on? Let me move this down below. There's nothing being added to that x, so b is 0 on this equation. But basically, in our in context, what this would mean, if you were on the line y equals x, what does this say about your height and your arm span? If you're on that line y equals x, what about your height and your arm span? You guys tell me, what does the y represent on this? What does the y represent in this scatter plot?
The height.
The height. Okay, so we'd have the height is the same as, what does the x represent?
Inches. I mean the arm span.
The arm span. Both of them are in inches. Good. So if you're on the line y equals x, that means your height is exactly the same as your arm span. Okay. So if you're on that line, the height would be the same as the arm span. So what I'm going to do is jump into the scatter plot, and I'm actually going to plot that line y equals x. So I'm going to edit this, and I'm going to go overlay this overlay polynomial order down here. I'm going to overlay a polynomial order 1. Lines are always 1. And then here, notice the C1 is in the place of the slope. It's the coefficient of the x. And so my C1 is 1 and my C0 is 0. Okay. And now I'm going to compute. And notice now I've got the scatter plot. And I've actually got the line y equals x drawn in here. Well, what does that tell me? What this does is it tells me that I can actually break my group into two. Actually, you tell me, what do we know about this point right here? And watch when I hover over the point. Is it going to give it to me? when I hover over the point, I can also hover over the line. I think my computer might be a little overloaded with Zoom. It's not giving me. Usually when you hover over this line, it'll tell you what it is on StatCrunch, but I think Zoom might be eating at my memory. And when you hover over a point, it'll usually tell you what that point is. But I think my computer's just being taxed too much. But anyway, what do you know about this dot sitting right on that line? They have the same height and the same arm span. And any point that's close to that line, these people have close to the same length for their height and their arm span. Now, this is not what's called the line of best fit. The line of best fit fits the points. The line of best fit, later on, we'll get to that, but the line of best fit would look more like this. It would wrap through the points. So I should actually color that something different. I'm going to color that green. Or maybe not. Anyway, the line of best fit is not what I'm looking at here. I'm looking at the line y equals x. And so all the points, if we were to name these points, for example, let's just name that one that's on the line. What do you think that point, what do you think their arm span is? And we'll just go to the nearest inch. What do you think their arm span is? If I go down to the x-axis, where's that point at?
73.
I think it's a little closer to 75, but yeah, 74, I think would be a little better guess. But you're looking in the right place. 74, you got to drop straight down. And then to the left, and if it's on the line y equals x, we know the arm span also has to be 74. So this point right here is 74, 74. What about this point over here on the far right? It looks like it's going to be, and I think I see it over here, 80, it's like 82. And the arms and the height is 76, I think it says in the bottom there. So the height is a little over that 75. So we've got this point over here, 82, 76. We can name these points. This looks like 69 on the x-axis and probably 68 on the y-axis. So what do you notice about these points that are below that line y equals x? What do you notice about the points that I've typed in besides the 74, 74, which is right on that line? What do you notice about all of these points? So these 3 points here, here, and here. Normally, I don't have to type them in. Normally, StatCrunch will show them to me. Oh, there they are. They do show me. Hey, I can see them now. So the height is 61.75. The arm span for this one is 62.5. So I got the height right, but I think this was 61.75, something like that. But what do you notice with all of these dots? 68.5 is the height, 69.5 is the arm span. This one, 69.25 is the height, 70.5 is the arm span. What do all these points have in common? On all these points, which is bigger, the height or the arm span?
The height.
The height is bigger. So notice I'm on this right now. Notice the height here is 68.5 and the arm span is 69.5. So for this point, which is bigger?
The arm span.
Arm span. How about for this point right here?
The arm span.
The arm span is bigger. And this one over here, the arm span, the X, 82 is bigger. And then this one right here, again, the arm span is bigger. So basically that line Y equals X, it just divided us into one group whose arm span was more than their height. And then this group over here, there seem to be more people over here. Notice all these dots have their height is bigger than their arm span. So just imagine, you know, what that kind of looks like. Like some of us have like longer arms than others proportionally. So this person, their arm span is a lot smaller than their height. So they're just imagine what that would look like. So all of these points on the left, their height is bigger than their arm span, and all of the points below that line Y equals X, their arm span is bigger than the height. But a lot of these points lie right across where so basically a lot of us have an arm span that's pretty close to our actual height. But that's the line Y equals X. And so again, with bivariate data, the key is you've got to understand what your X's, what your Y's are. And you can see a relationship using a scatter plot, but you just want to be careful with the relationship. You know, sometimes people tend to think, oh, one causes the other. No, you just see a relationship. There's an association. Doesn't mean that one necessarily causes the other, because this is just an observational study. It's not a controlled experiment. Okay, and just be careful about that. I'm going to stop my share now.